In this video, we are going to talk about something called asymptotes. What are asymptotes? Asymptotes are tangents to a curve at infinity. So say if you have a curve which goes on like this, and if this line meets the curve at infinity, then this is called asymptote. This line, which is the tangent at infinity, it means basically meaning that it's very close to the curve but it doesn't touch the curve. Okay, this is called an asymptote. So asymptotes are basically tangents at infinity. You have two types of asymptotes. One is horizontal, the other one is obviously vertical asymptote. Horizontal asymptotes might look something like this if the curve is going like this, and this would be your asymptote, horizontal one, which seems to meet the curve at when x is equal to infinity. Okay, vertical asymptote would look something like this. So you say this is the axis, and this would be your vertical asymptote, which means that it meets the curve at y infinity. Okay, so as you can see, this asymptote would be of the form y equal to k, and this would be of the form x is equal to k. There are also other asymptotes which are oblique. So if you have a curve going like this, and if you can have an asymptote something like this, which seems to meet the curve at infinity, the curve goes to infinity where it meets it. So this curve would be of the, this asymptote would be of the form ax plus by plus c equal to 0. This is oblique asymptote. So basically we'll have horizontal and vertical asymptotes in our course. Usually asymptotes are for functions which are called reciprocal functions, which are of the form ax plus b over cx plus d. So they have rational functions. We can also call them as rational functions which are in the rational form. Any functions of this type, say 2x plus 1 over x plus 1, would have asymptotes because they are rational functions. So what exactly, how do you find the horizontal and vertical asymptotes? It's not necessary that every function should have both. It might have one of them or it might have both. Even it can have even oblique as well. But we are only concentrating on horizontal and vertical now for the time being. So I said for horizontal asymptote is when the curve, the asymptote meets the curve at x is equal to infinity. So it's easy when you put, if you write this as y equal to 2x plus 1 over x plus 1, and if you want to substitute x is equal to infinity, then this would be of the form infinity over infinity, right? You can either use L'Hopital's rule, or you can do it this way as well. If you are not aware of L'Hopital's rule, you can just divide each denominator and numerator by x, and you can change it this way, and when you substitute infinity to x, you will have y equal to 2 here in this case. Therefore, as I told you, this line would be of the form y equal to k, and in this case y equal to 2 is the horizontal asymptote. So what about vertical asymptote? A few minutes before I said a vertical asymptote is when y is infinity. So if you have y equals to x plus 1 over x plus 1, and this y becomes infinity when the denominator is 0. Okay, so it's simple to find vertical asymptotes. Just make the denominator 0 and find the value. So x is equal to minus 1. It doesn't look like that, but here it should be somewhere in this place. So x is equal to minus 1 is our vertical asymptote. As I said, it's of the form x is equal to k. So vertical asymptote is x is equal to minus 1. What about this question? 1 minus 2 over 2x minus 3. So the two things that you are supposed to understand here is horizontal is when x is equal to infinity, vertical is when the denominator is equal to 0. So these are the two things that we need to remember. And when you put x is equal to infinity here, you will get 1 minus 2 over infinity, which is 1 minus 0, which is 1. Therefore, this is equal to y. So y equal to 1 is our horizontal asymptote in this case. What about the vertical asymptote? You need to make the denominator 0. So 2x minus 3 is equal to 0, which means x is equal to 3 over 2, and this would be our vertical asymptote. So the function would be between these two. X is equal to 3 over 2 would be somewhere 1.5, would be something here. This is 3 over 2, and y equal to 1 would be something like this. So the curve can be anywhere like like this. It could be like this. It could be like this, and it could be like this. We'll soon see how to draw the curve, how to sketch the curve just by looking at the function. Before we go deep into it, let's generalize this. If you have y equal to ax plus b over cx plus d, so horizontal asymptote is when x is equal to infinity, and you have to substitute, you have to divide the numerator and the denominator by x, so that you'll get b over x, so that you can substitute the value of x as infinity. So d over x, and when I substitute x is equal to infinity, here you can get a over c. So y equals a over c is the horizontal asymptote if the equation is of this form. And what about vertical? If the equation is this, then for vertical the denominator is equal to 0, therefore the vertical asymptote would always be x is equal to minus d over c. This is easy for you to remember. So let's try sketching a curve 3x plus 1 over 2x plus 4, which is equal to f of x. So if this is the question, without calculator, how can you sketch this curve? First of all, you need to find the asymptotes, either vertical or horizontal or both. Okay, so let's go for horizontal asymptote now. So this would be f of x is equal to, or y equal to 3 plus 1 over x divided by 2 plus 4 over x, or you can just directly write a over c as we just derived it. So y equal to 3 over 2 is our horizontal asymptote, and for vertical asymptote, denominator equal to 0, so x is equal to minus 2. This is our vertical asymptote. So let's start sketching the curve. Y equal to 3 over 2, which is 1, 2, 3, 1, 2, 3. Let me draw the asymptotes first. 1.5 for y, which should be along this. This is horizontal. And for vertical, x is equal to minus 2. So this goes like this. So the curve should be either in this part or here or here or here. So we should see how it goes. So for that, we need to find the x-intercept and y-intercept. What is x-intercept? X-intercept is when y equal to 0. So you just equate the given function to 0 and then find the value of x there. So 3x plus 1 equal to 0. So x is negative 1 over 3. This is x-intercept. For y-intercept, you need to put x is equal to 0, and therefore you get y equal to 1/4. So x is equal to negative 1 over 3 and y equal to 1/4 are going to be our x and y intercepts. So let me mark them. X is equal to negative 1 over 3, which should be somewhere here, and y equal to 1/4, which should be somewhere here. So this is going to cross this place. So obviously you can actually finalize it now. The curve has to go this way, therefore the curve should be of this shape. But we can check this by analyzing the behavior of the curve around the asymptotes. So our first asymptote is y equal to 3 over 3. So 3 over 2, 1.5. This is horizontal. So let's see how the curve behaves around the asymptote, around the horizontal asymptote. Okay, so when x is equal, when this is your equation, 3x plus 1 over 2x plus 4, how does it behave when y is more than 3 over 2? Maybe we can say y equal to 2. What is the value of x when y equal to 2? So you can substitute y equal to 2 here, so that you will get 3x plus 1 equals 4x plus 8, and when you simplify you get x is equal to negative 7, which means that x is negative above the y value, above the horizontal asymptote. So when y equal to 2, x is negative 7, therefore it has to be somewhere here. So somewhere here. So negative 7 and 2 would be the point for this particular curve. So I have removed all the other things at that place. So let's mark the point there, 2 and negative 7. So it's somewhere here, negative 7 and 2. What happens for y equal to 1? That is below the horizontal asymptote. Y equal to 1 would give us 3x plus 1 equals 2x plus 4, which in turn would give us x is equal to 3. So x is equal to 3, 1 is a point on the curve. Therefore, let me mark it, x is equal to 3, y equal to 1. So which is here, and we have already marked that place. But there is something in this place. We'll see what happens here. And then the next asymptote, this is for horizontal, and we need to find the behavior of the curve with vertical asymptote. Vertical asymptote was x is equal to minus 2. So if you have 0, minus 1, minus 2, 1, 2. So let's see how it behaves at minus 3, negative 3 and negative 1. So let's substitute x is equal to negative 1 first, which is y equals 3 times negative 1 plus 1 over 2, I think it's 2x plus 4. Yeah, 2 times negative 1 plus 4, which would be minus 2 over 2, which is negative 1. So the point is negative 1, negative 1. And then when x is equal to negative 3, you get 3 times negative 3 plus 1 over 3, 2 times negative 3 plus 4, which would be minus 9 plus 1 over minus 6 plus 4, which would be minus 8 over minus 2, which is 4. So the values are minus 3 and 4. So negative 1, negative 1, negative 3, 4. Let's mark them on the graph. Negative 3, 4 is somewhere here. So this is 4. And negative 1 is somewhere here. Okay, here. So the curve goes like this. So you can see that this passes like this. So there are some specific points. We have found this point, we have found this one, and this one. And we know that this is the asymptote. Therefore, the curve should cross through these 4 points and go like this. And also we have some 2 points here, and we know that these are the asymptotes. This is one asymptote and this is another asymptote. Therefore, the curve cannot cross these two lines. So the curve should go something like this. So your curve are in the purple colors. So those two curves are the curve which represent this function. Okay. So what exactly are the steps that gives you the clear sketch of a function? The first thing is you need to find the asymptotes, and you draw them in dotted lines. And then the next is x and y intercept. Mark them on the axis. Next is behavior of the function on either side of the asymptotes. So take 2 numbers before and after each asymptotes, and then of the asymptote, and then you can see how the function behaves, which side of the asymptote is the function. So when the number was negative in positive 1, you see that it was on this side, and when it was 2, it was on this side. So you know where it is. The same way for x value. X is negative on both sides of negative 2. On this side of the negative 2, the function was here. On this side of the negative 2, the function was here. So you can easily guess how this is done. Let's try to sketch this curve. Y equals 1 minus 2 over 2x minus 3. We just did this to find the horizontal and vertical asymptote. So what is horizontal asymptote here? When x is equal to infinity, you can directly substitute infinity here because there are no infinity, so there are no x values on the in the numerator. So you can easily substitute infinity and you get y equal to 1. For vertical asymptotes, the denominator is equal to 0, so you get x is equal to 3 over 2. So these are the two asymptotes, so you can just draw them on the axis. So let me mark the points. All these are important because you need to show them how you are spacing the values on the axis. So at least to some range you need to mark them on the axis. So the horizontal asymptote is y equal to 1 and the vertical asymptote is y equal to 1 and a half. X is equal to, x is equal to 1 and a half. So these are the two asymptotes and you have 4 places for the curve to be present there. Let's first find what is x-intercept. Is when y equal to 0. So 1 minus 2 over 2x minus 3 equal to 0. So x is equal to 5 over 2 is our x-intercept, which is 2.5, should be somewhere here. So this is x-intercept. What is y-intercept? It's when x is equal to 0. Putting x is equal to 0, you get y equals 1 plus 2 over 3, which is 5 over 3. So that should give us the point y is equal to 1.6, something like that. So it should be somewhere here. So we are just sketching, so you don't have to be very accurate on placing the points there. So we know that the points are on the opposite sides, so it's actually pretty easy to find out where the curve should be going. So if I could guess, let me use a light color. The curve should be going like this, but we can check it using the behavior properties. So what is the behavior of the curve before and after each asymptote? So let's start with horizontal, which is y equal to 1. So a point before y equal to 1 should be y equal to maybe 0. We can use 0. So what is the value when y equal to 0? We have already done y equal to 0 is here point. So let's have y equal to half. Therefore it is 1 minus 2 over 2x minus 3 equal to half. So when you solve this, you will get x is equal to 7 over 2. So the point is 7 over 2 half. We can mark them on the axis here. 7 over 2 and half, x is 7 over 2, 3.5 and half, so somewhere here. So our curve is actually going through that place. Let's find out what happens at the point above the horizontal asymptote. So we can take y is equal to say 2, which is above y equal to 1. So what happens when this function 1 minus 2 over 2x minus 3 is equal to 2? Which would be x is equal to half. So the point here is half and 2, which should be somewhere here. This is half and this is 2, so it's here already. We have the curve going through that point. Therefore the curve should be this way. So what happens to the vertical asymptote? So we know that the vertical asymptote is x is equal to 3 over 2. So a point before 3 over 2 could be 1, x is equal to 1, and if you consider x is equal to 1, the equation is 1 minus 2 over 2 minus 3 equal to 1 plus 2, and the value of x is 3. Value of y is 3. Therefore the point is x is equal to 1 comma 3. So if you look into the curve, the point 1 comma 3 should be somewhere here. This is 1 and this is 3, so the point is here, We have already gone taken the curve through that point, therefore it's okay. 1, and this is 1 comma 3, which is here, and we are correct in drawing the curve through that point. And then the next one would be, maybe we can take x is equal to 2. So when you take x is equal to 2, you can see that the value of y would be negative 1. So it's 2 comma negative 1, which should be somewhere here. 2 and negative 1 should be here, and we already have the curve through that point. So the points which we have found out here today are the x-intercepts, y-intercept, the point around the asymptotes here and here, here, and 3.5 half here. So these are the points that we have to draw the curve. Once we are done with these points, we can easily draw the shape of the curve. Okay, this is how we do this sketching of rational functions.